In this session, we will discuss 12 volt 25 ampere 300 watt SMPS switch mode power supply circuit. It is TL494 or KA7500 based SMPS. In my last video, I repaired this power supply. I found this IC was damaged and one of the resistor at VCC line was damaged. It was providing just only 4 or 5 volt in the output instead of 12 volt. In this session, we will draw its circuit diagram on this paper so that we can understand how the components are connected on this PCB. Because when we see components installed on the PCB, it is difficult to understand what is the role of this component. I will explain function of each component within this circuit, how it works and what is its role in the circuit. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are visiting first time to my channel, I will invite you to subscribe it. If you are returning viewer, I am thankful for tuning in. Here is input and output connector. 1, 2, 3. 3 lines are connected in this portion and other lines are connected on this portion. We can see 1, 2, 3 lines are connected to this rail and 3 lines connected to this rail. This point reaching here, then it is passing to this point. Here is fuse. After fuse, it is reaching at this point. And second line is reaching parallel to this line now. This from here, here and here, and this at this line. Here is a component, that is this box capacitor, safety capacitor, class X capacitor. Then both lines here. Here is a component, dual line filter. This line will reach here and this line will reach here. From this line, we have one component connected here, and on this line, one component here. That is connected at the same common point and it is reaching to third terminal. And also same line is reaching to chassis ground. That is connected to this body. So it is safety ground. Here is another component that is connected the same safety ground and output terminal. These are output terminals. So we will discuss this capacitor later on when we will study this output section. After this line, we have one component connected in both lines, neutral and line. That is this resistor. Then both lines are reaching to these two terminals, here and here. It is 4 terminal component, that is bridge rectifier. We have 3 lines, 1, 2, 3. Line, neutral. Line is passing through a fuse. It is T5AL, 5 ampere fuse. It is class X capacitor, that is safety capacitor. It is 0.1 microfarad, 275 volt. Class X capacitor, 0.1 microfarad or 100 nanofarad, 275 volt. Then this inductor, no value mentioned on the board. LF1 is just on the PCB marking. Blue color capacitor, class Y capacitor. JN222M, 2.2 nanofarad, both capacitors same rating. It is XY capacitor. For X1 rating 440 volt, for Y2 it is 250 volt. So it is 250 volt class Y capacitor. Then we discussed we have a resistor here. 6840. 680 kilo ohm resistor. Then both lines are reaching to this bridge rectifier. This is cut terminal, it is positive side, and this angle is negative side. The center two pins are AC pins. GBU 808. Let's study these components. Fuse, overcurrent protection. Due to any short circuit, due to any bad behavior within the circuit, if the circuit will try to draw more current, this fuse will open. So circuit will be protected from any overcurrent condition. That may be due to bridge rectifier failure, any capacitor failure, any power transistor, power MOSFET failure, whatsoever. Then we have this capacitor, this inductor, this resistor. It is 110 volts or 220 volt operated power supply, 50 or 60 Hz. Some power supplies are 120 to 220 volt input, that are universal power supplies. When we need high output, let's suppose 12 volt 25 ampere, so it is 300 watt power supply. It is without PFC, power factor correction circuit. So it will become very difficult to maintain line regulation, because in the output side we have very large window, that is 25 ampere at 12 volts. So load regulation is also very large window. And if you want to maintain power supply from 110 to 220, it is also big job. So SMPS controller cannot manage this window plus this window. So this power supply is provided with selectable option. We can operate it at 110 volt or we can operate at 220 volt. That is by means of this switch. We provide 50 Hz or 60 Hz. That are these signals: line, input terminal, input condition high or low. If line is going upside, neutral is going low side. Now when 60 Hz or 50 Hz signal is reaching here, this capacitor has high impedance because XC, capacitive reactance, is high due to 1 over 2 pi FC. So low frequency, high capacitive reactance. This capacitor will not affect on this low frequency signal. And XL, 2 pi FL. At low frequency, its impedance is normal. So it will allow to pass this signal. That is line voltage. Any abnormal noise, high frequency spike. Let's suppose we have a very short duration pulse. That is due to any external noise, any type of noise in both lines. For this short duration pulse, this capacitor will provide easy path. Low frequency will pass safely, but high frequency will be removed from this capacitor. This is high frequency signal, that is short duration pulse. Its wavelength is very short duration, narrow pulse. So this capacitor will remove that pulse because it will provide low resistance for high frequency signal. Same way here, when F frequency will increase, its inductive reactance will increase. It will provide high impedance for high frequency signal, and it will provide low resistance, low impedance for high frequency signal. So high frequency signal will be blocked from this side. If that signals are repeating again and again, this fuse will open circuit. It is differential mode noise. That noise is coming in line and neutral. If line signal is entering in the circuit, it is working normally. If power supply is working at, let's suppose, 50 kHz or 30 kHz, that high frequency switching noise will try to reach back to the line area. That pulses that are due to these transistors, transformer, that will try to reach back to the line area. Same way, that high frequency noise will be blocked by this inductor because we have XL and XC. It is also working as a resonant circuit. It is tuned circuit. So its tank frequency will block any high frequency noise that is higher than its tuned frequency from its corner frequency. Any noise from this side, if it will try to reach back, it will block. And here we have damping resistor, discharge resistor, that is this one. It is 680 kilo ohm resistor, but that time this will provide high XL for that 30 kHz spike that is being generated from this transformer, that is switching noise, that will be blocked from this inductor and that will be discharged from this resistor, EMI circuit. Then we have these two capacitors. These are class Y capacitors. Any noise appearing at only one line, either neutral or line, there are two capacitors, one in neutral, second in line. So this capacitor will provide easy path and it will discharge that noise in the body, in the chassis that is connected to ground or good earth. Differential mode noise from these components, common mode noise from these components. Either switching noise or either incoming noise in the line area. Then these voltage will reach to this bridge rectifier. If we have 220 volts input, multiply with 1.414 RMS voltage to convert into peak voltage. 220 multiply with 1.414, 311 volts. On this line, this is now positive because it is coming out from cathode and it is from anode. We will receive here 311 volt DC. This line 220 volt AC, here 311 volt DC. From here, these two components, these are jumpers. That are RT2, RT1, these are jumpers. These are just only to bypass this track from here to here. Negative voltage will pass from this side to this terminal. Capacitor negative terminal. This side, that is positive terminal, it is reaching to this point. That is positive terminal of this capacitor. So bridge rectifier negative side is reaching to negative terminal of this capacitor and positive is reaching to positive terminal of this capacitor. Positive and it is connected to negative. Center point of both capacitors, negative of this capacitor and positive of this capacitor, are connected to same terminal. So these are connected together. And then it is reaching to this point. Here we have a switch. Switch second side is connected to line input terminal of the bridge rectifier. It is 110 volt, 220 volt selector switch. When this switch is off, positive and negative peak. Positive peak is reaching from this line to this rectifier and it will reverse bias. It will pass to positive terminal. At the same time, this line is negative. Negative signal will rectified from this diode. So negative will reach here. Positive from this side, negative from this side. So these two diodes will respond to that signal. This portion. We will receive voltage here. Both capacitors are connected in series. So these will divide voltage. If we have 311 volts divided by 2, 155.5 volts. 155 or 156 volts on each capacitor. 155 here, 155 here. Total voltage 311 volts. If we close this switch, if we have 110 volts, that time this switch will provide this line to capacitor. That means positive peak will be rectified from this diode and it will reach here. Same time this negative side will reach here. What is the difference now? We have low amplitude pulse. Before this, it was 220 volt RMS. Now amplitude dropped. We have 110 volt. So 110 volt, this level. Before this peak and this peak will rectified by this pair. But now negative side is reaching directly to the capacitor negative side and positive is taken from this rectifier. So this capacitor will charge at 110 multiply with 1.414, 155.5 volt, the same voltage. Before this, pair was working, but now only one diode will work. So we will receive same 155 volt, and in next half cycle, when this line is negative side and this is positive side, the same 110 volt amplitude will reach. Positive peak is reaching at this point and negative will be rectified from this rectifier. So negative will reach here. So this capacitor will charge at same 155 volt. This point is now common point. Before this pair or this pair was working. When we close this switch, just only upper side two diodes will be used and these will rectify voltage and we will receive same voltage 310 volt. But this time the capacitors are charging one by one. In first half cycle, this will provide voltage to this capacitor and negative half cycle, this diode will provide charging voltage to this capacitor. 470 microfarad, 250 volt. In this power supply, very special point for understanding, if we are using in 220 volt operation range, this switch must be open circuit. It must be selected to 220 volt. If it is selected to 110 volt, 310 volt will be applied in case of 220 volt. So this capacitor will explode because its upper limit is 250 volt. So this capacitor and this capacitor will damage because when electrolyte capacitors are being operated at higher voltage than their rated value, its dielectric will fail. So this capacitor will damage. In parallel to both capacitors, we have two resistors. One resistor is connected here to here, the second here to here. So these are connected to common point. These are called balancing resistors, are also named as a bleeder resistors. These have two functions. First, these resistors will ensure balanced voltage on these two capacitors because these are also working as a voltage divider network. When power supply is removed, these will provide discharging path to each capacitor. Brown, green, yellow. 150 K. Then we have this capacitor. that is connected from center point, common point, to this terminal. 225J 400 volts. That means it is 2.2 microfarad, 400 volts, metallized polyester film capacitor. It is called coupling capacitor. It is connected to this terminal. Here is winding of this transformer. Second end of this winding is reaching to this point. This is primary winding of this transformer. In parallel to this winding, here and here, we have a capacitor here and 3 resistors. These 3 resistors are connected in parallel to increase power rating. From this point to this point, we have this capacitor. One capacitor from this point to this point, and second capacitor from here to here. And here we have resistors. 1, 2, 3. We can see them from these ventilation holes. Value of each resistor is 150, 150 ohm, 222, 1 kV. That means it is 2.2 nanofarad capacitor, 1000 volts. It is connected in parallel to this winding. Now we have this capacitor in series to the transformer winding. Positive voltage here and negative here. This is DC rail. In normal power supplies, we have just only positive and negative. But in this design, we have 3 lines: positive, negative, and this virtual ground. In normal power supplies, we are using this line as a power rail ground. But here, power rail ground is this point, that is after this capacitor, because it is half bridge topology. So this capacitor will allow only AC pulses, it will not allow any DC components. Second end of this winding is reaching to this transformer winding. That is this one, pulse transformer, signal transformer. It is also isolation transformer. We can see this winding, this portion, then it is reaching at this side that is connected to high voltage rail line area. But this side, from this side, this power supply is isolated. It is pulse transformer. It is connected at this terminal of this transformer. Structure of this transformer: this is in phase winding, but this winding is opposite winding to this winding. Positive line, that is this positive terminal of the capacitor, it is reaching to this component, and negative terminal from here jumped here and reaching to this point. Positive terminal is reaching to this center point, and this negative side from here to this jumper, and it is reaching to this terminal. Here center pin, here side pin. It is 13009 transistor, NPN power transistor. Right side pin emitter, center pin collector. This is base. Emitter, collector, base. Emitter of high side transistor, that is connected to positive terminal. It is connected to collector of this transistor. Its emitter is connected here, this emitter is grounded, and this collector is connected to positive side. This positive terminal is connected here, and this negative terminal here. It is connected here, and this is connected here. The same common point, this one and this one, is reaching to this transformer, this winding. When this positive voltage are applied here, negative voltage are applied here, these transistors will switch one by one. If this will switch, it will provide positive voltage to this winding, and this capacitor will provide that short duration pulse, that is charging time of this capacitor. It will provide a pulse duration from this capacitor. Because we are taking positive from here, the next half cycle, when it will turn off, this will switch, this negative side will pass from the same line. At that time, this capacitor will provide short duration pulse, and this capacitor will discharge in the winding because we are taking voltage from these 2 points. Before this, these 2 points, but now from these 2 points. That will cause to generate bidirectional current in this transformer. We have 155 volt in plus side and 155 volt in negative side. When one transistor will switch, it will provide this pulse in the winding. When this transistor will turn off, it will provide switching to this transistor. So from center line, we are receiving upside and low side voltage. Bidirectional magnetic field will be provided in this winding. In normal SMPS circuits, we have just only 310 volt DC. We control the duty cycle, but here we have bidirectional voltage. From reference point, from this virtual ground, we are taking upside and low side. One component that is connected between collector and emitter pin. The same here, this one, collector and emitter. This collector to this emitter, and from this collector to this emitter. These are two diodes. These are fast rectifiers. When magnetic field is collapsing, it will discharge that collapsing magnetic field high spike, so that spike will not damage this transistor. Its number is FR107. When we discuss computer power supplies for wine cooler, power supplies for playstations, industrial power supplies, that is two power supply based power supply circuits. One is low voltage power supply, that is primary power supply, or you can say auxiliary power supply. That power supply will take voltage from this DC rail. That power supply will start, that will provide biasing voltage, VCC voltage, to this high power section. First, small power supply will turn on, then the large power supply will start working. But this circuit is different. It is just only single power supply because its SMPS controller or PWM controller is in secondary side. There is no physical electrical connection between primary side and secondary side. Here is isolated, this portion is isolated. Just only this winding, primary winding, has its internal isolation, and this transformer, secondary and primary, are isolated. Technique to start up this circuit is kick-start circuit or self-resonant circuit. That will turn on by means of this pulse transformer, these power stage components, and these components. It will start and it will provide unregulated voltage to provide VCC voltage for this IC. Because for working any IC, any component, we need VCC voltage, we need some supply voltage. But this time there is no power supply in the secondary side. We have just only line, rectified DC voltage, and this circuit. Now we will configure the components in this portion. This 1,5 multiplier 0.1, 1.5 ohm, 1,5 multiplier 0.1, 1.5 ohm. Each transistor has 1.5 ohm resistor at its base pin. That is this resistor. This resistor here, same way this resistor here. 1R5. That is this resistor. Here is 1.5 ohm resistor, and we have two components here, 1 and 4007, and here is a resistor, that is 10 ohm resistor. A resistor here that is connected to rectifier. Same set here, this one, then this resistor. The same this resistor point, that is 1.5 ohm resistor, that is connected at this point, and diode anode is connected at this point. So we have a component that is coming in parallel to these two components, that is this capacitor. Capacitor negative terminal is connected to this resistor, negative terminal, and positive terminal is connected to anode. .7 microfarad, 4.7 50 volt. Both capacitors same value. Diode 1N4007, 1N4007 diode, this one and this one the same. And resistor is 10 ohm. 10 ohm. It is its base drive network. This capacitor point that is connected to diode anode side, capacitor positive terminal, it is coming at transformer this winding. Sorry, it is connected here. It is not connected here. Now we have two different driving points. This dot side is connected to this side, and this without dot side is connected to this point. So these will work in opposite direction because it will create phase difference in both windings. There are now base biasing resistors. Here is base pin, and we have a component between base to collector. This is 1.5 ohm resistor. After 1.5 ohm we have this resistor. That is 330 K resistor. From this point 330 K. The second side also 330 K. That is connected base to collector. Collector of this transistor is here. 330 kilo ohm. We discussed this resistor. That is connected from base 1.5 ohm resistor and collector pin. At the same point, we have another resistor. That is this one. It is connected from the same point. That is 1.5 ohm resistor and this, and it is connected between emitter pin. This small resistor. And here is small resistor. It has 2.6 K. And this point 2K6 positive base emitter. So it will provide a base biasing offset for this transistor, and this voltage divider network will provide base biasing offset for this transistor. So these bases are now ready to accept any signal. We discussed this diode, resistor. When it will switch, it will provide signal to the base. Base is ready to accept signal because we have voltage divider network for this high side transistor, and at the same time it is also ready to accept the signal. This emitter, that is low side emitter, that is connected to this negative side, same is connected to this transformer winding as well. This winding is also connected here. This negative terminal is connected here. Now this is our kickstart circuit. When we apply power, positive voltage will reach to this transistor, negative voltage will reach to this transistor emitter. How this kickstart or self-start circuit will work? Let's suppose I connected power supply to line voltage. Positive peak is reaching here. That is this positive peak. Negative is here. Positive peak is reaching to this side, this transistor. This end is now negative with respect to that peak. Current will flow in this winding and in this winding from this point. When current will flow in this winding, due to this capacitor, this winding, because it will take some charging time, that pulsed voltage will create a small pulse in this winding. This winding is in phase. So in phase, that means if it is going to positive side, this positive voltage will reach to this transistor, it will switch. When it will switch, it will allow positive voltage to pass here. So this transformer will create magnetic field. It will produce voltage in its winding, both windings. We have two different windings, now we will discuss. At the same time, this winding is opposite. So it will reverse bias, because if this end is positive, this end is negative. That is connected to this transistor. When this capacitor stopped charging, because it is just only 2.2 microfarad, that will charging time, discharging time. Then current will stop. When current will stop, magnetic field will start to collapse. Voltage here will reverse and here will reverse. When voltage will reverse, this will cut off and it will start to conduct, because now voltage polarity due to collapsing magnetic field will change. So this transistor will start to conduct. When it will start to conduct, it will provide negative side voltage, that is this one, from this emitter to collector to this winding and here. Before this, the positive voltage were flowing in this side, but now negative side, current polarity will change. So it will cause to discharge either upper side capacitor or lower side capacitor for a specific time, that is just only charging or discharging time of this capacitor. So transistor will start to conduct one by one by means of changing magnetic field from this transformer, from this pulse transformer. It is called kick start or self start or self resonant circuit. When we have magnetic field here in this transformer, in this winding, we have two windings here now. One winding here, that is this winding. This common point, it is center taped winding. This is one winding end and this is second winding end. There are two rectifiers. Now common here, rectified positive voltage will reach at this side. In output side, we have 1, 2 and 3 points for the output winding. This common side, this winding and this winding. Then here is rectifier. Its output terminal is here, cathode is here, center tape cathode. Cathode from here connected to jumpers, that is jumpered here in the output side capacitors. So positive voltage will reach in the output terminal. But negative side connected to this inductor, then it is connected to another component that are RM1, RM2, RM3, RM4. But here RM2, 3, 4 are connected, RM1 not connected. It is current sense resistor. Immediately after the inductor, that is one side of this resistor is taken out and second side of the resistor is also taken out. So two lines are reaching here. So we have 1 point, 2 point. This side is connected here through a jumper to this winding ground side. This is current sense signal. How much current will flow in this resistor? The voltage drop across this resistor will be taken out as a reference. Now this is negative out, this is positive out. We have these four components. 10 ohm resistor and 4.7 nanofarad 1 kilovolt capacitor that is connected across this rectifier. This is one output winding. One capacitor from here to this point, second capacitor from second side, this winding. And then it is connected to this resistor and this capacitor is connected to this resistor. It is connected to the output terminal. One capacitor, one resistor, one capacitor. It is RC snubber for this rectifier for its fast recovery. 30 CP. It is common cathode rectifier. It is 4.7 nanofarad 1 kilovolt and this resistor 10 ohm 1 watt. This capacitor and this resistor will help this rectifier for its fast recovery, so rectifier will not overheat. 340 ohm resistor in the output terminal, 340 ohm 1 watt, and another capacitor to remove the ripples, that is decoupling capacitor, 100 nanofarad 100 volts. And we have these capacitors 1, 2, 3. 3 by 2200 microfarad, 16 volt capacitors. Now this set that we discussed in this portion, this line, that is common cathode output from the rectifiers that are connected underside of this transformer. Positive voltage from here and negative is connected to the common point. These positive voltage will reach to this jumper and it will reach to this capacitor, that is here. It is VCC capacitor. This side is negative and this side is positive. 100 microfarad, 35 volts. This is negative terminal of this capacitor. Negative, positive. This positive is coming from this rectifier pair and negative is from the center tape winding of this transformer winding, that is VCC winding or auxiliary winding. Positive voltage from here are connected to a resistor, that is this 1.5 K resistor, 1520, 1.5 kilo ohm. Resistor second side is connected to this transformer, this winding. VCC1, we will name it VCC1. This VCC1 is connected here. From this resistor, the voltage are reaching to center tape winding of pulse transformer driving side. Same positive voltage are reaching to this point. Here we have a resistor that is connected to number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to pin number 12 of this IC. From this point we have a resistor here. It is TL494 or KA7500. Pin number 12, that is VCC pin. So these are VCC voltage. I will name it VCC. That means it is connected at this point. This was center tape winding of auxiliary winding, VCC winding, and it is also output ground. It is reaching to this point. It is connected to pin number 7. 1, 2, 3, 4, 5, 6, 7. This is pin number 12, VCC pin, and this is pin number 7. It is ground. This is output side ground pin. So this IC will receive that voltage that are being generated by its kickstart circuit. When this circuit will start self-resonance, it will start switching by means of this winding, these transistors, this winding. So we will receive VCC voltage for this IC. In that time, we will receive voltage in the secondary winding, maybe 5, 6, 7 volt up to 15 volt. These are uncontrolled, unregulated voltage. If the IC is present or not present, we will receive voltage. If this circuit is working good, no component is damaged, pulse transformer is good, transformer is good, we will receive voltage here and here. If we are not receiving voltage, that means kickstart circuit or self-start circuit or self-resonant circuit is bad. We need to troubleshoot this portion. We connected to 120 volt, we will receive 310 volt on this rail. 155, 155. In that condition, it will switch approximately 20 to 30 kHz, 40 kHz. That is a random frequency. When we will receive VCC voltage for this IC at pin number 12, this resistor, here I connected 15 ohm. In last video, when I was repairing this power supply, this IC was damaged. Due to damaging this IC, this resistor was damaged. In some circuits, we will find this resistor and sometimes we will not find this resistor. It is, you can say, current limit resistor, or it is to match the VCC voltage with the IC specifications. It is from 1 ohm to maybe 47 ohm, 33 ohm, like that. Low value resistor. We can also jumper it. When we received VCC voltage, ground, it will provide reference voltage that are 5 volt. Any SMPS controller, when it is receiving VCC voltage, it will generate its reference voltage that are precisely regulated voltage, temperature compensated voltage. That is to create a fixed frequency, that is to bias up its internal error amplifiers, because if we don't have any regulated power supply, any operational amplifier, any comparator will not provide good result. If we have any frequency circuit is directly affected, because most of the time that is using VCO circuits, voltage controlled oscillator circuits, that will charge, discharge its capacitor, that is timing capacitor. If voltage are fluctuating at reference pin, that IC will never maintain its switching frequency. That error amplifiers will never adjust the outputs, because error amplifier cannot decide what is the voltage value at supply pin and what is the output. We provided VCC voltage pin number 12. This is pin number 13 and this is 14. Pin number 14 is a reference pin. From pin number 14 we will receive reference voltage. And pin number 14 is directly connected to pin number 13. Pin number 14 is connected to pin number 13. If pin number 13 is connected to ground, this IC will work in single-ended operation. This IC will switch two transistors, upper side, lower side, to work in push-pull mode to operate the circuit in half bridge or full bridge driving. Each transistor will switch one by one. If one will on, second will off. If this pin number 13 is connected to ground, both drives will work together. So this IC will work in single-ended operation. If it is connected to reference voltage, 5 volt, that time it will work in push-pull. One is on, second is off. One is off, second is on. So opposite switching will be there in the output stage. We said pin number 7 is grounded. 8, this is pin number 9, this is pin number 10. Pin number 9 and 10 are also grounded. 9 and 10 are emitter sides, output transistors, because in output side it will use transistors that are built in within this IC. Original IC of this circuit was TL494. I used KA7500 IC. Here is pin number 6. 8, 7, 6. Here we have component that is connected between this ground pin and pin number 6. That is this resistor 2, 2 and orange 3. 22K. Pin number 6, 22K. It is RT, timing resistor. Pin number 5, a component here. Here resistor and here capacitor. It is timing capacitor, pin number 5. It is 102J, 1 nanofarad, 100 volt. It is timing capacitor. When these two components are connected here, that is 22K resistor and 1 nanofarad capacitor, these are timing components. Its internal RC oscillator will start to oscillate. When it will oscillate, it will generate frequency. Then here is pin number 4. 8765, and this is pin number 4. We have a resistor here. Brown, black, orange. 10K resistor. This is pin number 4. It is soft start. 10 kilo ohm. Anytime pin number 4, that is soft start pin or dead time control in TL494, it is shutdown pin. If pin number 4 is above 1 volt, the IC will not work. It will remain in off state. It must be pulled down to ground level, to this level. So this pull down resistor will ensure this IC to start working, keep functioning. If there is any remote control signal, external power on signal, that will be connected at pin number 4. In normal power supplies that are computer power supplies or any TL494 power supplies that have external power on signal, power on command, PS on command, that time this pin will be connected to that remote control signal, maybe from any optocoupler, maybe from any switch. When it will be connected to ground, this IC will start switching. Then we have pin number 3. 1, 2, 3. We have a capacitor here and resistor here that is connected between pin number 3 and 2, and it is also connected to this component that is here, and we have capacitor here that is connected between pin number 15. We will discuss later on. It is error amplifier section. Now we will see pin number 8. Pin number 8 is connected here, and it is connected to this point. Here we have a resistor that is connected to this capacitor positive terminal. This is pin number 8. 9 and 10 are grounded. Pin number 11. 11 is connected to this component and it is connected here. And pin number 11 is also connected here. A resistor between positive VCC capacitor positive terminal and pin number 11, and resistor between pin number 11 and ground pin. Here is 9 and 10 that is connected to ground side. Pin number 8, this transistor, this resistor between ground side and pin number 8, a resistor between VCC capacitor and pin number 8. So we have pull up and pull down resistor for pin number 8 and 11, and that are connected to these transistors. Pin number 8 is directly connected to this transistor base, and pin number 11 is connected directly to base of this transistor. Collector is connected to this winding, collector of this transistor, this jumper, to this one, that is this jumper. We can say both emitters are connected together. These are connected at this component. It is in series with this component. Here we have two diodes that are 1N4148 diodes, and these are connected to ground side. 1N4148. We have C1815 transistor. In parallel to each transistor, From collector to emitter, from this collector to emitter, we have a protection diode, Zener diode, 1N4752 transistor. That is Zener diode. 1N4752A. It is 33 volt Zener diode. It will protect these transistors when there is reverse EMF due to switching noise in this side, because here we have switching. That is due to its kickstart circuit, or maybe from this side. So it will remove all negative spikes. So it will protect the transistor from over voltage stress. Transistors 2SC1815. We said we have two resistors that are connected between base pin positive and here the same, this transistor base pin ground side. One resistor here, that is 1.5K, that is low side resistor, and upper side resistors that are here. This is the second resistor for second side, this one pair and this second pair, 1K5, 3K9, 3.9K and 1.5K. These will provide biasing voltage to the base, and it will also provide base biasing. So one transistor is connected here, second is connected here. One is connected at pin number 8, second is connected at pin number 11. If it is high, it will turn on. It will provide this ground through this transistor to the winding of this transformer, and it will provide current from this resistor, from this VCC winding. IC received VCC voltage from here, and this current limit resistor is connected here. So ground from here, from these offset diodes, these will provide 1.4 volt offset due to internal transistors of this IC. 0.7 plus 0.7, 1.4 volt diodes are connected in series to compensate the voltage drop in the transistor here. Now we can say we provide VCC voltage, it generated reference voltage. That reference voltage will bias up its internal circuit. That internal circuit will start oscillation. That oscillation will start switching at specific frequency based on this RT-CT components. Now we need regulation. How this circuit will regulate? TL494 works with two different type of regulation system. One is voltage regulation, the second is current limiting. Two error amplifier at pin number 1 and 2, and error amplifier at pin number 15 and 16. Pin number 15 and 16 are used to monitor the current, that is this signal, that is voltage drop across this resistor. Pin number 1 and 2 will monitor voltage from output terminal. Let's see that components now. Pin number 3 is compensation, error amplifier compensation. Now we discussed pin number 9, 10 connected to ground, 11 drive pin, 12 VCC pin, 13 is control signal control pin to operate this IC in single-ended or push-pull. So now it is connected in push-pull because reference voltage are applied to pin number 13. Pin number 14 reference pin. This pin is connected here. Here we have resistor. This resistor, 68K resistor. 68K resistor is connected, and same reference voltage are connected to this resistor that is beside this IC. Pin number 14 and this resistor 5600 5.6 K resistor. 68 K resistor second side is connected to this resistor. That is 620 ohm resistor. That is this resistor 68 K. The same point, that is this voltage divider network, it is connected to pin number 15. Pin number 14, 68K, and this resistor, this is voltage divider network point. It is connected at pin number 15. We can say this point is connected to pin number 15. This line is reaching to this point. We can say sense signal S. It is reaching here S. Current sense signal is reaching at this point. The same point that is connected at pin number 15, we have a component, that is this capacitor. It is 103J 10 nanofarad capacitor 100 volt. This pin number 15, nanofarad 100 volt. It is connected at this component. Here we have a resistor, that is this resistor 5600 5.6 K resistor 5K6. This resistor, it is reaching out to pin number 3. 1, 2, 3. This is compensation signal. Pin number 16. Here is pin number 16. That is connected to this component. That is this 1K resistor. This one. Here is 620. This is 1K. 1K resistor is coming from the second side of this current sense resistor that is connected to ground. So pin number 16 is connected to ground using 1K resistor. Pin number 16. 1 kilo ohm. It will provide reference and it will compare this signal with this one. Voltage drop across these 2 points will be provided to pin number 15 and 16. As I said, pin number 15 and 16 is current error amplifier. How much current is flowing in the circuit? So this IC will calculate how much current is there. If overcurrent condition in the output side, it will control its switching so that transformer, power transistors, all components will remain safe. Now we'll see voltage regulation. Here is pin number 1. Pin number 1 is connected to this component. Here is jumper. This jumper. It is reaching this line. It is coming here. Here we have a resistor. That is this one. It is 2.6 K resistor. Pin number 1, jumper. 2.6 K resistor. Same is connected to another resistor that is connected at same point. Pin number 1 has 2 resistors. One is connected here, second is connected at this point. That is 220 ohm resistor. 2.6K, 220 ohm, and then this 220 ohm resistor is connected to the second resistor that is connected here. That is connected at positive output terminal. This is positive output terminal. This terminal, this is positive output terminal. It is connected to 1, 2 and 3 zeros, 12K resistor. Then it is connected to 220 ohm, 220R, and then it is connected to third resistor, that is 2.6K, 2K6. Common point of 2K6 and 220 ohm is taken out to pin number 1. Pin number 1. Here is pin number 1. This 2.6K resistor is connected with this component. Here is 3 terminal component, that is potentiometer, trim port 102. Second side of this trim port is connected to output ground. Slider arm is connected to it. So we have adjustable voltage. It is 1 kilo ohm trim port. From this positive terminal, the top side resistor, 12K resistor, second side of 12K resistor is connected to capacitor. Value of this capacitor is 33 nanofarad, 100 volt. Positive terminal resistor, capacitor second side is also connected at same point. So this positive line is reaching to this connector. This connector is for fan, cooling fan. Any noise from cooling fan will be removed from this capacitor. Voltage divider network will receive any fluctuation free signal for a voltage sensing. This outer line is for fan. This side is ground side. This line is voltage sense line, that is coming to pin number 1. Now pin number 2. Pin number 2 is connected to this resistor, that is 5.6K resistor, and also a resistor between pin number 2 and ground. Pin number 2 and this resistor. It is 5600, 5.6K. 5.6K, 5.6K. Ground. It is connected to pin number 2. 5K6. Now we can see pin number 14, reference pin, 68K and 620 ohm resistor, this low resistor and this high resistor. It will provide few millivolt reference for pin number 15. So current sense signal from this pin will be very minor signal. But here 5 volt reference is divided into 2.5 volt. 2.5 volt reference is provided, and 2.5 volt from this pin will ensure the voltage regulation. This is pin number 2. We discussed this resistor. And we have another resistor that is connected at the closer point to this 5.6K resistor, and it is connected to capacitor. Then it is reaching to pin number 3, compensation pin. 22K resistor with this capacitor, that is 22 nanofarad capacitor. Pin number 3 is connected internally, 22K and 22 nano. It is compensation. Pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is our reference pin. We have this line. It is reaching to this point. Here we have a capacitor. That is this electrolyte capacitor. 1 microfarad 50 volt. Pin number 14. Pin number 14. 1 microfarad 50 volt. From the same point, positive voltage, reference voltage, this positive terminal is connected here to this resistor. Here is 120K resistor. Positive terminal, in parallel to this capacitor there is 120K resistor. It is working as a bleeder resistor. So it will provide slow charging because it is in parallel to this capacitor. At the same point, that is negative side of this capacitor, is reaching to pin number 4. 1, 2, 3, 4. That is this point. This soft start circuit, reference voltage are provided to capacitor one side. Second side of this capacitor is connected to this 10K resistor and ground. So this level will start to build up slowly. So this capacitor will start to charge slowly because 120K and 10K resistors are here. And it will power on. The reference pin will receive voltage from this IC. This capacitor and this side is connected this point. We have voltage divider network 10K, 120K. This capacitor is empty, it will work as a short circuit because it will need high current for charging. A limited charging current from this side will here. Upper side resistor is low because now capacitor is discharged. 10K resistor is high. More voltage will drop here, so pin 4 will receive some offset voltage, some high voltage. When this capacitor will start charging, because limited current is provided to this capacitor. Here is 120K, here is 10K, this is low value, this is high value. So voltage will start to decrease at pin number 4 because now capacitor is charging. In that charging process, this IC will start switching slowly. It will not start a sudden switching cycle so that its transistors, its power components will remain protected. In the output side, we have this 10 nanofarad 2 kilovolt capacitor that is connected here. Negative side, it is connected with this ground. So this is the circuit diagram of this power supply. In upcoming session, we will rearrange this circuit, redraw this circuit in Proteus software so that this diagram will become in some good looking shape, and then we will perform cold testing and live testing. We have output LED, that is this circuit, It is 1K resistor, LED, positive V out. One kilo ohm, LED and ground. When voltage will reach at specific level, this LED will turn on. Line and neutral are provided here. EMI circuit will protect this circuit from any abnormal noise, from differential noise. Upside or low side or upside, both lines. It will remove that noise. It will block that noise. And it will also block any switching noise due to this transformer that will try to ride on the line and neutral. This tuned network will provide high impedance to that noise. If noise is present in any neutral or line, any single line that is common mode noise, that will be removed from these capacitors and that will be connected to chassis ground. Then we have bridge rectifier, 220 volt AC are applied. It will provide rectified peak voltage. Here we provide RMS voltage, here we receive DC voltage. Peak voltage. That voltage are stored on these smoothing capacitors. These will divide that voltage by 2 because two capacitors are here. 155 volt, 155 volt, that is in case of 220 volt operation. If you have 110 volt line voltage, this switch will be closed. That time, this center point will be connected to neutral side. Each capacitor will charge one by one. Before this, these were receiving rectified voltage from pair of diodes. This one, or this one and this one. The voltage are stored here. In both cases we will receive center point to plus side 155 volt, center point to negative side minus 155 volt. Balancing resistors or bleeder resistors will balance the voltage in these capacitors, and these will also discharge these capacitors when power supply is removed. Positive voltage are reaching to collector of this transistor, that is 13009. Either here is MOSFET or IGBT, the condition will remain same. Positive voltage here, negative voltage here at emitter. Freewheeling diode FR107 are connected here. Series coupling capacitor is connected in series with the transformer primary winding. It is connected to pulse transformer, this winding, that is portion of high voltage transformer. It is used to generate switching as a kickstart circuit, and it is connected to center point of these two transistors. Here is base biasing network for upper transistor, base biasing network for lower transistor, current limit resistor for each transistor, that is 1.5 ohm resistor. Here is pulse forming network, diode, resistor, capacitor. When we plug in, if this capacitor is starting charging first time, that time this upper side transistor will switch and it will allow voltage to discharge this capacitor in the winding, so current will flow. If this capacitor is started charging, reverse current flow will in this winding. It will cause to turn on this transistor. That will depend on the starting pulse, that which cycle is reaching first time on the transistors, either this or this. We will receive this switching pulse here in the winding. RC snubber circuit here will remove these spikes that are switching noises, so purified square wave will reach in the winding. it will remove these spikes. When this kickstart circuit will start switching, we will receive voltage in output that are unregulated voltage. We will also receive voltage here in this VCC winding. VCC voltage will reach to this transformer, and also VCC voltage will reach to this IC VCC pin. Ground is connected here. It will provide reference voltage. Reference voltage will provide it to its oscillation circuit that will create specific fixed frequency using these two components. This voltage divider network will provide reference to pin number 2. Pin number 16 is pulled down with 1 kilo ohm resistor. So pin number 15 is now started to sense current signal. Pin number 2, reference voltage. Pin number 1 is used to sense the voltage regulation that is composed by these components. 12K resistor, 22 ohm resistor, 2K resistor and 1K potentiometer. It is to adjust the output voltage level. Voltage drop across this 1K resistor and 2.6K resistor is applied to pin number 1. It will compare with pin number 2. 2.5 volt reference is provided here at pin number 2 when pin number 1 and pin number 2 have different voltage level. This IC will try to adjust its duty cycle to increase or decrease the voltage level based on these two values. These will switch these transistors in push-pull configuration. So if this will switch, it will provide switching to this transistor and its signal will reach to this one. Before this, the voltage was uncontrolled, but now the voltage are controlled because this IC is now taking control because it is receiving VCC voltage. In upcoming session, we will redraw this circuit. We will rearrange this circuit using software, Proteus. And then in next session, we will perform cold testing and live testing. If you have any question, if you have any observation, please write in the comments. If you enjoyed this reverse engineering, give a thumb up. I will attach the link of this diagram in the video description as well. If you have not subscribed my channel until now, subscribe it. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.